So if you're a programmer, especially in C or C++, you've been told your program starts with the main function, right? It's like the starting gun for the race. But what if I told you that's not the whole story? That there's this incredible secret journey your code goes on before a single line of main even runs?
Yeah, I love this quote from Philip Johnston. He says, most of us are blissfully unaware of this hidden world. And it's so true. It's kind of like thinking a Broadway show starts the moment the star walks on stage, totally forgetting about the set being built, the lights being rigged, all that backstage magic that has to happen first.
So that's the million-dollar question, isn't it? Where does it all really begin? Well, that's what we're going to do. We are going to pull back that curtain and trace the entire path, right from the moment you hit save on your code to the very second it comes to life.
All right, our journey actually starts way before the program ever hits memory. It starts on your hard drive. This is all about building the blueprint for your program, taking that human-readable code you wrote and turning it into a single file that the machine can actually understand, what we call an executable.
This whole transformation happens in 4 key stages. You've got preprocessing, which handles all your includes and macros, then compiling, which turns it into assembly code, assembly converts that into machine code, and finally, linking, which is what puts all the puzzle pieces together. Let's zero in on that compiler step for a second. Its job is pretty simple on the surface. Translate your code. But here's where it gets really clever. The compiler is usually split into 2 parts, a front end and a back end. And this design is what makes it so incredibly powerful. And this table just lays it out perfectly. The front end is kind of like the language expert. It grabs your source code, checks it for grammar, syntax and semantic errors, and then turns it into this generic, middle-of-the-road format. Then the back end, the engineer, takes that generic code, optimizes the heck out of it, and spits out the final machine code for whatever computer it's going to run on. Pretty smart, right? Okay, so after the compiler and assembler have done their thing and created all these individual chunks of code called object files, the linker comes in. You can think of the linker as the master builder. It takes all your code, grabs any code from libraries you're using, like the one for printf, and stitches it all together into one solid executable file. This is the final step in creating our blueprint. So, we've got our executable file. The blueprint is complete, and now it is showtime. The moment you go to run that program, the operating system steps in and starts to prepare the stage. The key player here, the real MVP, is the OS loader. Think of the loader as the ultimate stage manager. Its job is to grab that executable file from your disk, get it into memory, and do all the initial setup to get it ready to go. Now, one of the very first and most important things the loader does is create something called a virtual address space. This is basically a private workspace for your program. It's a huge deal because it means your program gets to act like it has the entire computer's memory all to itself. This keeps it from messing with other programs and keeps other programs from messing with it. Every program gets its own private theater to perform in. And this virtual space isn't just some big empty void. Oh no, it's highly organized. You've got the text section, which is where the actual executable code lives. Then you have the data and BSS sections for your global variables. The heap is like a big open area where you can ask for memory as you need it. And the static is where all your local variables for functions live, constantly growing and shrinking. It's this beautiful dynamic system that keeps everything running smoothly. Okay, so the stage is set. The memory's all organized. We're so close to running main. But wait. There's one more critical and almost always invisible step, and this is where we meet the true unsung hero of our story. Here it is, the big twist. The very first piece of your code that the operating system actually runs is not main. No, the true entry point is a little function that's usually called _start. This function is the real beginning. It's a small chunk of code, often written in low-level assembly, that your build tools sneak in there for you. And its entire job is to do the final setup before handing off the baton to main. So what does this mystery function actually do? Well, _start is like the roadie doing the final sound check right before the band comes out. It initializes the stack, it sets up the whole C and C++ runtime environment, it gets all the command line arguments ready for main, and then, only then, it calls main. And get this, when main is done, it's _start that cleans everything up by calling exit. It literally wraps your entire program.
Let's dig into that runtime setup for a second, because this part is absolutely crucial. This is the moment where all those uninitialized global variables finally get set to 0. If you're a C++ programmer, this is where the constructors for your global objects get called. It's also what fires up standard input and output, which is why things like printf and count even work. It's the final, meticulous prep work before the main event.
So, with all that backstage preparation done, with the workspace created and the runtime environment fully initialized by our hero, _start, the moment we've all been waiting for has finally arrived. The curtain rises on main.
And here is why all that setup matters so much. By the time your code in main starts to run, the whole environment has to be stable, predictable, and, well, correct. I mean, think about it. Your code just assumes that memory is there, that I/O works, that your global variables exist. This entire pre-main journey is designed to guarantee that all those assumptions are true, so your code can just focus on doing its job. So let's just recap the whole secret journey one last time. It all starts with you writing your source code. The build tools, your compiler, and linker create the executable blueprint. Then, the OS loader sets the stage, creating a process and its private memory space. Our unsung hero, _start, does the final runtime setup. And then finally, main gets to run. And when it's all over, the process is terminated cleanly.
You know, we started with this really simple idea that a program begins at main, and we ended up uncovering this whole complex, hidden dance of compilers, linkers, and loaders. It really makes you wonder, doesn't it? What other things in computing that we just take for granted as magic are really just another elegant, well-defined process, just waiting for us to get curious and discover it?